In this video, we are continuing our Quiz 5 review, and we'll review truth tables. So I want to look at an example which says, determine whether these two propositions, the first one is P and Q in parentheses, or R, and the second one is not P implies R, and not Q implies R, are logically equivalent using truth tables. So I want to begin by having you pause the video for 3 minutes to try this one on your own first. 4, 3, 2, 1, pause it and try it for 3 minutes. Alrighty, so hopefully you did that. Hopefully you paused it and tried it for about 3 minutes. So I'm going to start this off by building a truth table. And there's 3 sort of simple propositions I'm going to need, which are P, Q, and R. Okay, so I'm going to put a double vertical line to separate those. And now, to test if two propositions are logically equivalent, I will need to build both of these propositions in my truth table and make sure that they have the same truth table outputs. Okay, so I'm going to build these up in my truth table. So for the first proposition, I would need P and Q. And then I could build out P and Q or R. Okay, so I'll put some columns to separate these. And on a quiz, if I were to ask a question like this, I would definitely ask you to include all of these columns that build up each of the propositions that we have. So I don't just want to see the final column. I want to see your whole thought process that leads up to it. Alrighty, so for the next proposition, I'll need not P. We'll need not Q. And then we could do not P implies R. Then we could do not Q implies R. Not Q implies R. And then finally we can build this whole AND statement, which is not P implies R and not Q implies R. So let's separate these. I need some columns. Alrighty. Alright, so I'm going to start with R and alternate true, false. True, false, true, false. True, false, true, false. For Q, I'll alternate double trues, double falses, double trues, double falses. And then for P, quadruple trues, and then quadruple falses. Alrighty, so for P and Q, this is only going to be true if both P and Q are true. So that happens in the first row and the second row. But in all the other rows, at least one of P or Q is false, and that makes the AND statement false. So let's put falses all the way down. And now I have to make an OR statement, where the first part is P and Q, and the second part is R, so this column. And the only way for an OR statement to be false is if both of those parts are false. So where does that happen? That happens in this 4th row, both of the parts are false. It happens in this 6th row, both parts are false. And then in the last row, both parts are false. In every other row, at least one of those two parts is true, which makes the OR statement true. Alrighty, so next let's do not P. So not P is going to be the opposite of P. So all these trues will become falses. These all become falses. And then all the falses become trues. Trues, trues, trues. And then not Q is going to be the opposite of Q. So the trues become falses. So we'll have falses here. We'll have some falses here. And then the falses become trues. So trues there, trues there. Next we need not P implies R. So here's the not P column. Here's the R column. So the only way for an implication to be false is if the first part of it is true, but the second part of it is false. So let's see, I'm looking at the parts where not P is true. So in any of those, is the second part going to be false? Well, yep, it happens in this row, the 6th row. So there it's going to be false. And then it also happens in the 8th row. The first part is true, the second part is false. So in all the other rows, this is going to be true. Alright, so let's put those in. A bunch of trues. A bunch of trues. Alright, so now let's do not Q implies R. So same thing. For this to be false, I need the first part of it, which is not Q, to be true, but the second part, which is R, to be false. So I'm looking at the rows where not Q is true. And in the fourth row, R is false. So that makes the implication false. And let's jump down to these trues. And in these ones, in the eighth row, R is false. So that makes the implication false. In all the other rows, the implication is going to be true. All right, and then finally, I got to put the previous two columns together and make an AND statement with them. So an AND statement is going to be true when both parts are true. So that happens in the first three rows, it happens in the fifth row, and the seventh row, where both parts are true. And all of the other rows, at least one of them is false. So I put falses. Alrighty, so now if we look at our two propositions that we wanted to test. So we wanted to test this proposition to see if it was logically equivalent to this proposition over here. So we're looking at their truth table outputs to see, are they exactly the same? So we're looking at this column and this column, and they are exactly the same. They're true in the exact same spots and false in the exact same spots. So they are the same, which means they are logically equivalent. So I got to state that and then justify why. So P and Q, or R, our symbol for logically equivalent is we put sort of an equal sign with three of these horizontal lines. The second is not P implies R, and not Q implies R. That's our second proposition. These are logically equivalent since their truth table outputs are the same. Truth table outputs are the same. And that is our answer.